Hello, and thank you for joining me for today's lesson on masses of atoms and atomic mass calculations. So my goal for this lesson is at the end of this, you will be able to calculate the atomic mass and the mass number of an atom. You'll be able to identify differences between isotopes of the same element, and you'll be able to explain why each element has an average atomic mass and not just an atomic mass. Why we need that average. So for starters, back to things we've covered. So kind of a quick review. Each element has a symbol. So elements are made of symbols on the periodic table. It has at least one, but no more than 3 letters. The first letter is always capitalized. All others are lowercase. And symbol comes from the names, location discovered, scientists involved, Latin terminology, something that's relevant to what we discovered. So Ag comes from the Latin word for silver being argentum. So argentum is the Latin word for silver, so that's where Ag comes from. All right. Now, how do we tell atoms apart? What is the difference between sodium and potassium? Other than the letters here, because we assign those, that's not a big deal. What else is different? You'll notice there are 2 other numbers. So I have 11 and 19 up top, and I have 22.99, and I have 39.0938 on bottom. The one that we're going to concern ourselves with is this number up top, which is known as the atomic number, and this number is equal to the number of protons in the nucleus of that atom. So sodium has 11 protons. Potassium has 19 protons, and that's how we differentiate between the two. And so if I would change this sodium atom and I would give it 8 more protons, it would now not be called sodium, it would be called potassium. So if I change the proton number, I change my substance. But what if I change the electron number? So what if instead of, for example, atoms are neutral by nature, like normally they're neutral. So fluorine has an atomic number of 9, which means it has 9 protons in the nucleus. It also has 9 electrons on the outside because positives and negatives have to be equal. But what if fluorine gains an electron? So now it's got 10 electrons on the outside. Well, this fluorine atom is going to have a charge. It's going to have a -1 charge because there's one more negative than there is positives. We call these ions. So ions are atoms that have charges resulting from gaining or losing electrons. So this fluorine gained an electron. Over here we have sodium, which again has 11 electrons. It has 11 protons, 11 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice that on this side, this last electron was lost. So this becomes a sodium ion because it's got one more proton than it does electrons on the outside. So this is how we form what we know as ions. They gain or lose electrons, which give them a charge. Now there are 2 types of ions. You just saw fluorine and sodium. Fluorine gained an electron, became negative. Sodium lost an electron, became positive. We have names for this. So we have 2 terms, cations and anions. Cations are atoms that lose electrons, giving them a positive charge. So if you think about, ready for my art skills? I have a cat here. I can make a plus sign for the nose. And you can think cats are positive, which is really not true, but we'll go with it for now. Cats are positive, or cats have paws. So cations are positive ions. Anions, if you've ever been on a picnic before, or been to a park, and you get fire ants in your shoes and they bite you, are you a very pleasant person? Answer, that's probably no. So ants make you very negative. Anions gain electrons and have a negative charge. So anions are negative, cations are positive. Really quick, pause the video or think to yourself, how are element symbols written? How do we identify atoms? What's different between sodium and potassium? And then what are ions? If you can answer those, we will continue on. All right, now we're going to talk mass number. When we talk about the mass of an atom, the mass number of an atom is equal to the sum, which means addition, of the number of protons and the number of neutrons found in the nucleus. So down here is kind of your equation. Mass number equals atomic number, which is number of protons, plus your number of neutrons. So protons plus neutrons equals mass number. And how we're going to use this a lot is we're going to solve for and calculate the number of neutrons. So I can take my mass number minus my atomic number to get my number of neutrons. And so here we go. So in this case, we have symbols here. This is isotope notation. So this is my element symbol. This is iron. In the top left, you're going to see the mass number. So 54 is my mass. I can look at the periodic table, and I can find that iron has an atomic number of 26, which means it has 26 protons. If I take my mass number minus my atomic number, I can calculate this number of neutrons, which is going to be 28. So that's what we've done here. So manganese has a mass of 56, atomic number is 25. 56 minus 25 equals 31. And same for neptunium and carbon here. On the next slide, I have some for you to practice with. So here I would like you to fill in the symbol at the top. Give me my number of protons, number of electrons. We're going to assume they're all neutral. Calculate the number of neutrons if needed, or calculate the mass number if needed. Pause the video, perform those calculations. I will give you your answers on the next slide. So here are the answers. You should have chlorine for the first one, cadmium for the second, 35, 35, and 79 going down, 48, 48, and 64 on this one. If we got different numbers, stop in and see me and we'll see where we missed at. I may have miscalculated as well. So stop in and see me, we'll figure it out. Alright, so what is the difference between carbon 12 and carbon 14? So thinking about what you just learned, what is the difference between those two types of carbon? And then why are there two different kinds? So what's different about those? What does that mean? And what that actually means is we have what are known as isotopes. So isotopes, those two carbons, carbon 12, I'm just going to use C, call it C12 and C14. These are isotopes, and isotopes are atoms of the same element, meaning they have the same number of protons with different number of neutrons. And the way we know there's a different number of neutrons is because the mass is different. Remember, the neutron had a charge of 0 but a mass of 1. So because protons and neutrons both have mass, that's where we get our difference. This table here is showing you the isotopes of hydrogen. And so hydrogen 1 is known as protium, or hydrogen. It has 1 proton, it has a mass of 1, meaning it has no neutrons. Most of the hydrogen in the world is protium. Deuterium is known as heavy hydrogen, hydrogen 2, meaning its atomic number is still 1, it's got 1 proton, but this time the mass is 2. In order to have a mass of 2, I have to have both a proton and a neutron. And then the last one we have is tritium. Tritium is very, very rare. So tritium is hydrogen 3, which still has atomic number 1 because we're talking hydrogen. Mass is now 3, which means I have 1 proton and 2 neutrons in the nucleus. So those are isotopes of hydrogen. These are some examples of radioactive isotopes. So not all isotopes are stable. They have too many neutrons or not enough neutrons, and so they break down and try to become more stable, try to balance out that number. So these are atoms that break down over time through what we call nuclear decay, which if you take chemistry in a couple years, you will learn more about that. And then with this, we have what we call an average atomic mass. And so on the periodic table, you have an atomic number, and that number at the bottom for sodium and potassium that I showed you earlier on, that number at the bottom was the average atomic mass, which is a weighted average of all the masses of the isotopes. And so when you calculate just a regular average, you just add them up and divide by the number. We're talking a weighted average here, which requires that you take the mass of the atom multiplied by the percent abundance. So this 99% is how common it is. So 99 out of every 100 pieces of carbon are carbon 12. The one that's not is carbon 13. So this is 99% carbon 12, 12 times 0.99, the percent made a decimal, and 13 times 0.01, which is 1, made into a decimal. And so if we take and add these two numbers together, we get 12.01. If you look at your periodic table, you will see that the average atomic mass for carbon is 12.01. And this is how we calculate that. And so if 4 out of 5 boron atoms are boron 11, and 1 out of 5 is boron 10, to find the weighted average, we would take 4 out of 5 is 80%, so we would take 0.80 times 11 AMUs, and we would add it to 0.20, which is 20%, times 10 AMUs, to get an atomic mass of 10, I believe it's 10.8 is our average atomic mass for boron. But we're going to do some practice with this in the next video. I would like you to label these three parts of the atom, or parts of the periodic table. Just in your head you can do it, or on a piece of paper. So what does this number 6 represent? What does the 12.0107 represent? And what does the C represent? 1, 2, and 3. And then your last couple questions. I want you to know, what is an ion? What is an isotope? How do we use both of these? Why are they important? And then what is the average atomic mass of an element? What is it? How do we find it? How do we solve for it? Thank you much for your time and attention today. I look forward to continuing to learn about atoms with you and working through our understanding of chemistry. For now, enjoy the rest of your day, and I will see you next time.